Okay, now we are starting O-level physics 5054, paper 1, variant 2, October, November 2024. It is 1 hour paper with 40 MCQs over there. Okay, here he is saying over here that the diagram shows a closed patch. Okay, closed patch over there. And height is given. Which device should be suitable for obtaining the accurate value for the height of the closed patch? Okay, so for the closed patch is, I think so I should go with the diameter to calculate very small with more precision over there, because here he is saying go with the accurate value for the height of the closed patch. So my ring tab is not perfect. Meter rule is not so much precise. So I will use for micrometer screw gauge for more accurate. And for the volume of the miring cylinder is used for volume calculation, so it will not be included over there. If we go towards question number 2 over there, which set of quantities are all vectors over there? So acceleration, displacement, and velocity, it is the vector quantity over here. Acceleration is having the direction, rate of change of velocity. Displacement is the shortest distance between 2 points in a proper direction. A rate of change of displacement in a proper direction. So it is all for vector quantities. Chemical energy is a physical quantity. For scalar, mass is just like a base quantity. Power is derived quantity. Extension, force is vector a little bit, but gravitational potential energy is scalar over there. Weight is vector quantity. Remaining two are scalar quantities. So I should not go with them over there. Here he is saying over here that the graph shows motion of a cyclist during the ride that lost in 14-second distance time graph. For 14 seconds he is given. What is the average speed of the cyclist for the ride? So if I look here for the time total he has taken over there, from here if I go that it is 2 points over there. So 10, 11, 12, 13, 14, 15. So 15 is there. It is 12.5. 12.5, 13, 13.5, 14. So it is 14-second total. And the distance calculated is 20, 21, 22, 23, 24, 25, 26, 27, 28. So it is 28 divisible by the time was 14 seconds. That is 2 meter per second over there. So I will say here that it is 2 meter per second. Total distance traveled over total time taken, that is 2 meter per second is the speed value over there. So option A will be perfect for it. Always take total distance traveled over total time taken for getting the average speed over there. If we go to the question number 4 over there, it's saying the diagram shows how the velocity of a train varies with time. So velocity is positive, getting zero value, then it is in going negative, then it is going coming to positive again. Which section of the graph shows where the magnitude of the velocity of the train is decreasing? Okay, which two is decreasing over there? So from positive to zero, it is confirmed that during the P region, it is going on. So option D is not to be considering over there. So for getting its value to decrease in magnitude over there, I will say it is R and it is P only. If I go with it, then I will say it is option B will be fine for it. During this, from magnitude decreasing over there, and during this magnitude is decreasing over there to get the zero value over there. I'm not talking about this positive and negative signs to be taken into account, because he is talking decreasing speed, decreasing velocity, and both will be taken into account over there. After that, he is saying a metal disc is squeezed in the jaws of a vice. Okay, in the jaws of the vice over there. Okay, this is the vice. Metal disk, it's the micrometer screw gauge. Which property of metal disk is unchanged when it is squeezed? Its mass, its radius, distance between these atoms, forces between its atoms. So in general, if we go with it, we will say its mass will not decrease. Remaining all, like when it is squeezed, maybe its radius is going to decrease, its distance between atoms will also decrease, so that it can be squeezed, it can be decreased in the size over there, and forces between the atoms will also going to decrease over there. When we go for the question number 6 over here, he is saying that the gravitational field strength in space is smaller on the earth's surface. In space is smaller than on the earth's surface. How are the mass and the weight of the satellite affected by the satellite moves away from the surface to the earth into space? Okay, so he is talking about how are the mass and the weight. So when we go to the space, we know about the formula W is equal to mg. Then g is decreasing. It means weight is decreasing, and mass remains constant over there. So according to option, both mass and weight are unaffected is not going to be correct. The mass decreases and the weight decreases. Mass can never be decreased over there. Mass increases not possible. Mass is unaffected and weight decreases. This will be the right option for this question over there. Okay. Now he is talking about a material has a density of 2.4 gram per cm cube. How much the density will be in kilogram meter per cube? Okay, so centimeter cube is 1000, gram is by 1000. So I will say here that it should go with the gram centimeter cube to kilogram per meter cube divided by 1000 because of this kilogram. And we should take for it centimeter cube to meter cube. So I'm going to simplify and solve it. 2.4 multiply centimeter is basically 10 raised to power minus 2. So I will say it should go with power cube also. So centimeter per centimeter cube. So I will say here it will go like 10 raised to power 10 raised to power 2. I'm taking this upward to whole power 3. And on the other end, when we go with the kilogram to kilogram, I will have to divide by 1000. So I will say here 2.4 multiply 10 raised to power 6 divided by 1000. So it will be giving us 2.4 multiplied 10 raised to power 3. If I expand this in normal number value form, it will be 2400 kilogram per meter cube over there. So this is my right option for this answer over there. Okay, here he is saying that an object falls vertically through the air. Which diagram represents the forces acting on the object? A. Force of the air on object. Force from the earth on object. Okay. Uh, an object falls vertically through air. Which diagram represents the forces acting on the object? Force of the air on the object definitely in the form of air drag upward, and force from the earth on object in the form of weight downward. So I will say it is air drag, which is right over there, and it is a weight which is acting downward. So I will say it is the right option for this answer over there. But let's check the other one. Force of the air never goes far down. Force of the air never go far down. Force of the air on object upward is correct, but force on the earth, an object that is weight, is not going upward over there. It should always be directed towards the downward position over there. Okay, so A is right for it. In the question number 9, he is saying a force F is being taken into account is applied to a lever at a distance L from the pivot as shown. Okay, this is the L, this is the pivot, this is force, and this is the distance which he has given over us over here. He is saying length D is perpendicular to the distance between the force and the pivot. So, which expression for the moment? According to the definition of moment, We know star is equal to F multiplied by R in the form of perpendicular distance. So force should be multiplied by distance. So option C should be fine for it. Remaining all options are not going to satisfy the definition or formula of the moment over there. Here he is saying that a rocket is launched vertically upward by a constant force from its engines. And here he is saying the data from the launch is shown, okay. And weight of rocket is 1.9 mega Newton. Average air resistance is 0.1 mega resistance Newton. Force of engine is 3.5 mega Newton. How much work done on the rocket is used to increase the speed in the first 100 meters over there? So, force on engine is 3.5, weight of the rocket, and this. So, I should go for subtracting both of these values, then it is 2. Then I will say here how much force is being taken. Then it is 2.5, 3.5 minus 2 minus how much the work done on the rocket is used. Okay, so I will say here that it is 1.9 plus 0.10, that is 2.0. So I'm getting 1.5 mega Newton. So for 100 meter, for first 100 meters, he's asking how much the work done should be taken over there. So as we know that the force into distance over there should be taken into account, and this is mega Newton, this is mega joule. So I will say here that it is 150 megajoule for this answer over there. I have simply said over there that it is force into distance, that is how much work done. So work done is 1.5 mega Newton. When I will multiply it by 100, I will get its answer as 150. Mega is remaining as it is. So mega joules. So it is mega joules over there. Okay, I think so. You have got this concept behind it. I have simply used the formula W is equal to FD, and I get the accelerating force for traveling that distance over there. And I have just subtracted the weight of rocket and average resistance to get my force, and force is multiplied by distance of 100 meters, and I got in the form of megajoules over there. Here he is saying which equation is used to calculate the efficiency of energy transfer over there. If we look useful energy output over total energy input, yeah, it's correct. Output energy over input energy will be fine. Total energy input, no, never in the numerator. Total energy output over total power input, sorry, no, both the quantities should be the same over there. Should be same over there, otherwise I can't use this. And efficiency, useful energy should never be multiplied, it should be divided or like that. Okay. Four objects of different masses are lifted um, through different distances in different amounts of time. In which combination of mass, distance, and time is the greatest power transferred during this relation over there? Distance 2 meter in 3 seconds, and mass. Okay. From here, I can calculate the work for all of them. In which combination he is saying more power is being consumed. So I am taking here the formula as mgh over time to get my power. So in which combination this power, greatest power transferred. So according to this, I will say mass is 2 into 2 into 10, 2, height 2, and time is 3 seconds. So I will say it is 40 over 3, which I can say 13.33 watt. For this one, I will go with the 1.5 into 2.5 into 10. If I go over 2 seconds. Let me check on my calculator over there. What is its value? Then I will say here that it is 1.5 multiply 2.5 multiply 10 divided by 2. 10. I think so. I have done something wrong over there. 1.5 multiply 2.5 multiply 10 divided by 2. 18.75. So it is 18.75 watt as my power over there. For the next one, he is saying over here, 2, 1.5 and 2. Okay, I will go again over here. 2 into 2 into 10 over 1.5. If I say over here, that is 40 over 1.5. So 40 divided by 1.5 equals to 26.66 watt. After that, he is saying 2.5 and 1.5 and 1.5 seconds. Okay. So I will say here 1.5 into 2.5 into 10 divided by 1.5. So 1.5 multiply 2.5 multiply 10. Wait a second. 1.5 multiply 2.5. 2.5 multiply 10 divided by 1.5, 25 watt. So from checking all of these values, I will say here that C is the right option because he is consuming much more power. So it is 26 according to its greatest value. I will say here that he is saying it is the right option for this C over there. Okay, let's go to the next question over there. He is saying at air at pressure 1 multiplied 10 to the power 5 in the piston, okay, is trapped in a container by a piston. A force is applied for pressure is 1 multiplied 10 to the power 5. Okay, a force is applied to move the piston down into the container. The temperature of the air remains constant and the distance of the base of the container and the piston decreases 0.18 meter to 0.15 meter. Okay, what is the new pressure inside the container over there? So 1 multiplied times power 5 is the pressure is trapped in a container by a piston. So he's saying over here that 0.15, 0.03. According if I take the change in volume over there, then I am saying 0.18 minus 0.15. So it is 0.3. And if I look at what is the new air pressure inside the container, so volume changes this. I will have to go for getting the new pressure over there. So inside, because the volume is decreased, then definitely its pressure will increase. And if I look on my values, 0.69, 0.83, these are the decreased values. So I will have only to go for C and D over there. So I will say here that the distance between the base of the container, base is remaining as it is. So P is equal to P delta V is going to get the work in the form of energy over there. Pressure is remaining as it is, like 1 multiplied 10 raised to power 5 and change in volume is as it is like area into height is equal to being taken. Area is remaining as it is, so W is there. So work can be taken as 1 multiplied 10 raised to power 5. So what is the new air pressure? So I need a pressure over there. Wait a second. I want to erase all of this so that I can divide it by getting the different value over there. I need a pressure. Pressure is equal to force over area. I am multiplying here length, multiply length. This is my volume. And length is changing, and this F over A, I simply say here F over A should be taken, but the volume should be there. There is a weight that is going to compress this. That is 0.3. The distance between the base and the container and the piston decreases from 0.18 to 0.15. Only the height. So I'm getting mgh in the form of that. mgh, and I'm taking into P delta V. From here, if I get volume in the form of density is equal to mass over volume. So mass over density should also be involved. That is not be required over there. Density remains the constant for it. So I will say it is 1.2 multiplied 10 raised to power 5. I think so I should go with it. 1.2 multiplied 10 raised to power 5 for it. Okay. A sealed gas range contains the gas that is kept constant by this range. Okay, which row describes how a change in temperature of the gas is affects its pressure. Okay, so we can say here that it is when pressure is being increased, it means temperature is increasing over there. Temperature increasing over there, and pressure of gas is also increasing over there. When you are pressing this syringe inside, gas syringe is going inside, pressure is increasing and temperature inside it is increasing. Temperature decreasing, no, because the molecules are going to continuously strike with each other, and temperature decreases, and this is also going to be taken into account. Okay, the melting point of gold is 1064. What is the melting point of gold in Kelvin scale? Just add 273 into it, and you will get the answer in the form of 1337. Just add 273 into it. Add 273 Kelvin for getting or converting it into Kelvin over there. Now he is saying the table shows the melting and boiling point of the boiling temperatures of three elements, argon, nitrogen, and oxygen, at which temperature are three elements and in different states over there. So by looking melting point and their boiling points over there, we can simply say here that minus 220, minus 220, minus 220. Minus 220. No, it's minus 220 will be less. So minus 218 not possible. 205 is not possible for argon. Minus 190 is suitable for all of them to go with it. All three gases will be acting in the different states over there. Okay, let's move on the next one over there. 17. The diagram shows a liquid at room temperature in a beaker. What reduces the rate of loss of liquid by evaporation over there? What reduces the rate of loss? Blowing air, and then sorry, not possible because it will increase. Heating the liquid will also increase over there. Okay. Putting a lid on the beaker. Putting the lid on a beaker will also decrease. So yeah, it will reduce now. So I will go with this. If I put a lid over this beaker, then rate of evaporation will decrease over there. Okay, at number 18, he is saying what is the color and what is the texture of the best absorber of infrared radiations. So, best absorber. So, it should be black or dull like that. So, we will say that it should be B over there, black and dull over there. Not shiny. White and shiny is a good reflector only. White and dull. Dull is correct, but white is not going to be perfect over there. Which row gives the velocity and the wavelength of a wave that is an ultrasound wave over there. So for going towards ultrasound, I will say the velocity should be 1500 and wavelength should be 6 centimeter, so that it should be ultrasound over there. Velocity and wavelength, then frequency will not lie in the, if I use the relation V is equal to F lambda over there, then I check according to the frequency, then it will lie according to this value over there. Now he is saying here that the diagram shows angle of incidence of 30 degree. What is the angle of refraction? So for this one, I will have to draw the normal over here. As I know, normal is perpendicular to the mirror line. That is 60-degree angle of incidence, and this is 60-degree angle of reflection over there. So it will be 60 degree for this answer. For number 21, an object is this, image is this is the mirror. Okay, he's saying that it is upward and it is going upward, uh, is exactly on this one. And so I think so A is, because literally inverted can be possible, but upright stays upright. Option A is fine for it. A is going downward, no. He is making the image on the mirror, no. On the mirror, no. Here he is saying that the ray of light. This is the 42 degree, this is 49 degree point 5. Critical angle of the boundary between the medium Q and R. So critical angle, I need that. What is the shore traveling from medium air to medium Q? So what is the critical medium for this one? So it should be increasing like 42, and if I go here, this is my angle of incidence. If I subtract 90 minus 42, 48 degree is my angle of incidence. It is still showing angle of refraction over there should be taken. So if I go to calculate for this one, what is the critical angle of the boundary between the medium Q and medium R? So I can get first 49 is there, 150, 31 over here. First I will calculate the refractive index, sine I over sine R. When I will get the refractive index, then I will use this refractive index value over there with n is equal to air to medium this is going. So I will say angle of refraction, sine of angle of refraction over sine of critical angle critical. So from here I will say here that I am replacing this angle of refraction in case of critical angle is 90 degree, 1 over this value will be like 1.5 over there if I go for it, 1.5. And if I go with the sine inverse, I'm taking this approximate value, I'm not getting the exact value after the calculation over there, so I'm just using this as approximate value. So and critical angle which I will take here, that is 60.9. By using this way, first calculate the refractive index and then apply on the critical angle formula with respect to refractive index over there. Which two waves are the components of electromagnetic spectrum? Light and sound. Sound is not there. So ultrasound and ultraviolet, no. Water waves, no. X-rays and microwaves are the part of the electromagnetic spectrum over there. After that, he is saying over here, the diagram shows an iron nail in four different situations. Iron nail, okay. Magnet A, in which diagram is the nail induced magnet? Is the induced magnet over there. So, magnet, iron bar, okay, in this case only, we can say here with option A over here that this is an induced magnet. But in remaining cases, it is going to become electromagnet. It is going to be electromagnet. It is iron bar only. It is induced magnet already. Which row is correctly shows a magnetic metal and non-magnetic metal over there? So I will say here magnetic metal is aluminum, copper, steel, iron, copper, steel, iron. So steel is a little bit we can take, but if I hear he is asking about correctly about magnetic metal and non-metal. So copper is non-metal, non-magnetic metal, and iron is magnetic metal over there. After that, he is saying a freely suspended magnet is held perpendicular over there. So, in a uniform magnetic field shown, the magnet is viewed from the above. Okay. What happens to the magnet when it is released? So, what happens released? Okay. It turns 90-degree clockwise, it turns 90-degree anti-clockwise, and then stops moving. So, it's right. It will stop moving over there. It will turn and it will stop moving over there. After that, he is saying a plastic rod becomes charged when it is rubbed with a cloth. Which statement gives the reason for the charge on the rod? Due to friction over there. So, some electrons will be transferred from one part to another. Then, from where they are moving away, that is positively charged, and which is receiving, that is negatively charged. So, I will say here that it is the plastic rod loses electrons and becomes positively charged over there. For resistances and EMF, he is saying what is the current? Um it is 4R. So what is the current in each resistor? It will stay as the same because it is they are connected in series over there. So it will staying the same over there. So total resistance should be divided 1, 2, 3, 4. It is 4R. So according to Ohm's law, I is equal to V over R. So V is E as electromotive force over 4R. In all four resistors, it will stay the same. So it is the right option for A. How can 1 volt be also can also be expressed? 1 coulomb per ampere. Now 1 coulomb per joule, 1 joule per ampere, 1 joule per coulomb, 1 joule per coulomb because the voltage has or the volt has potential difference that is equal to W over Q, that is joule per coulomb will be taken into account. After that, he is saying X is a piece of a wire of length L, area and resistance R. Wire Y is made from the same material and is connected to wire X to produce a component with the total resistance of R by 2. Okay. What are the diameters of Y and how is it connected to X over there? So if we look at this, then we will simply say here that total resistance is R by 2. And Y is made up of the same material and connected wire to produce a component with resistance, total resistance R by 2 should be half over there. So if I look option A over there, 2L and 0.25. So I know the formula is R is equal to rho L over A over there. And if I go with it, then resistance R by 2 is not possible. If I go for B is also not possible. If C is going for this one, then it is possible, yeah. Which circuit contains a fuse and a diode? Fuse and a diode should be taken into account. Okay. Yeah, this is called fuse over there. Fuse and diode. Fuse and diode. It is having lamp, resistor, and diode. It is having fuse, lamp, and variable resistor. He was asking contains a fuse and diode. Fuse and diode. So option D will be fine for it. It is having fuse. It is having diode. How is energy transferred within a kettle when power man supply? By electrical work done into chemical energy? Hmm. By electrical energy, by electrical work done to thermal. Yeah, electric kettle, thermal energy. After that, a magnet moves through a coil of wire as shown. Okay, when we move in and out, then it will going to generate some EMF over there. Magnet is produced at the two ends of the magnet, and magnet leaves the coil. Which pole is induced at pole P? When the magnet in Q, okay, the magnet leaves the coil. So pole at P, when magnet enters the coil should be north, okay, and when pole at Q, when magnet leaves should be north. So option A will be fine. Okay. After that, he is saying over here a straight vertical wire carries a current in the direction shown as observer. Okay, vertical wire is given. What is the pattern of the magnetic field around the wire seen by the observer viewing the wire from the position shown? Okay, when we are taking this one in the form of outward scene, okay, what is the pattern? So it should be not in a regular pattern, like equidistant, it should not be. So A and B are gone. So it is in the form of anti-clockwise. No, it should be clockwise. So option D will be fine for it. Okay. Which part of the simple DC motor reverses the direction of the current in the coil once every half rotation of the coil? Like armature, carbon brushes, slip rings, no, split ring commutator over there. Okay, this is the responsibility of split ring commutator to reverse the direction of, like, this is positive half cycle for AC, negative, positive, negative, positive, negative. So for getting positive, negative alteration of the EMFs over there, we will have to take into account all of this over there. Which statement about the nuclide of notation? R is atomic mass, Z is atomic number is correct. R is the nucleon number, which is different for different isotopes of X. He is right. So R is the proton number? No. Z is the nucleon number? No. Z is the proton number, which is different. No. So option A will be fine. After that, he is saying over here for 37, during the radioactivity experiment, the background reading is 28 counts per minute. A radioactive source is 2 centimeter from the detector and its detectant counter. Okay. Counter readings are taken with and without sheets of different materials of being source. No sheet 750, thin card 750, 5 millimeter thin aluminum. So beta rays should pass through them, but alpha rays should be stopped over there. What type of radiations are being emitted by the source over there? So I will say here uh, beta particles and gamma particles. We got aluminum sheet of 5 millimeter sheet. Alpha will already be stopped, no sheet when it is taking some airs over there. So beta will be blocked by 5 millimeter thick aluminum. So beta and gamma over there. A radioactive isotope is injected into a patient at a part of a medical test. The radiation emitted is detected outside the body. What is the suitable properties of the isotope? So, if we look at this, radiations which should have stay inside the body for few hours over there. If I take alpha, it means it is will cause too much ionization and cancer is or deterioration of the tissues, internal tissues can be there. Beta is still having some ionization power, so gamma for few hours it should be perfect. Years is also not perfect again, so I will say gamma rays are there for few hours which can pass at very high speed and will not deteriorate the tissues of the patient over there. After that, a student writes the statement about the solar system. Light takes approximately speed in seconds to travel from the sun to the earth. What? Light takes approximately itne second. Not possible. This is the speed. The earth takes approximately 24 hours to rotate about its axis once. Yeah, that's fine. The moon takes approximately 1 month to orbit the earth. The sun takes approximately 365 days to orbit the earth. No, earth takes. So 1, 2, and 3 are fine over there. So 39 should go with the C over there. This one is right and this one is right. But this one is wrong and this one is wrong. What is never formed by the explosion of the red supergiant? So a black hole, no. A neutron star, no. A white dwarf. White dwarf can be made from the supergiant over there. Thank you so much. This was our paper, and I think so much more good way it is done. We will check this again, and we will.